Good day everyone. Let us try to solve some examples under one-dimensional motion problems with constant acceleration. For problem number 1, an object moves the distance of 50 meters in the time interval 5 seconds with an initial velocity and acceleration of v sub o and 2 meter per second squared respectively. Now the question is, what is the initial velocity? We will use the following kinematic equation to find the unknown initial velocity. Distance or change in distance is the sum of half of the product of acceleration with squared of time and the product of initial velocity with time. Now the given values here are the distance, which is equal to 50 meters, acceleration of 2 meters per second squared, and a time interval of 5 seconds. Then these values will be substituted to the given formula and the result is equal to 5 meters per second as the initial velocity of an object. For problem number 2, an object without a change in direction travels a distance of 53 meters with an initial speed of 6 meters per second in 5 seconds. Now find the object's velocity at the end of the given time interval. In this problem, we will find the value of the final velocity. The formula for the final velocity is the sum of initial velocity and the product of acceleration with its time. We cannot directly use this formula to find the final velocity because we don't have the value of acceleration. So we need to find first the value of acceleration. We can use the distance formula in terms of acceleration. Now the values from the given problem are 53 meters for the distance, meters per second for initial velocity, and 5 seconds for the time interval. Now if we substitute the values to the distance formula, the result is equal to 1.84 meters per second squared as the acceleration of an object. Then we can now directly use the formula of final velocity by means of substituting the solved value of acceleration and other known values from the given problem. Then the result is equal to 15.2 meters per second as the final velocity of an object. However, we can use another method to solve this problem. Since we have two unknowns in the problem, acceleration and final velocity, and the motion is constant, acceleration, one can use the total displacement formula. Now substitute all the given values to the formula and the result of the final velocity is equal to 15.2 meters per second. The same as the first method that we have used. Let us proceed to problem number 3. A car starts its motion from rest and a constant acceleration of 5 meters per second squared. Now the question is, what is the average velocity of the car in the first 6 seconds of the motion? The given values are the acceleration, which is equal to 5 meter per second squared with a time of 6 seconds. Now the formula for the average velocity is the sum of 50% of the initial and final velocity. Now the problem is, we don't know the value of final velocity. Now let us solve for the final velocity. Final velocity is equal to the sum of initial velocity and a product of acceleration with time. Now substitute the given values to the final velocity formula with an initial velocity of 0. The initial velocity is equal to 0 because a car starts its motion from rest. Therefore, the value of final velocity is equal to 30 meters per second. Now, directly substitute the solved values to the formula for average velocity. The result will be equal to 15 meters per second. How about for problem number 4? A particle moves from rest with uniform acceleration and travels 40 meters in 5 seconds. Now, at what distance from the origin is this particle at the instant of time is equal to 15 seconds? The given values are 40 as the distance with 5 seconds, then another time of 15 seconds with an unknown distance. Then we will use the kinetic equation of the distance formula in terms of acceleration and velocity. Then substitute all given values to the formula, and the result is equal to 3.2 meters per second squared as the acceleration of the object. Now we will use the same formula to solve for distance, but the value for the time is equal to 15 seconds. And the value of acceleration should be substitute. Then the result is equal to 360 meters as the distance of a particle moving from the origin. Let us solve this next problem. Problem number 5. An object starts its trip from rest with a constant acceleration. At instant time is equal to 3 seconds is 1 meter away from origin. And at time is equal to 5 seconds is 12 meters away. At the moment of starting the motion, the object was at what distance away from the origin? Now, the initial velocity of an object is equal to 0. Then, when the object moves in 3 seconds, the object creates a distance of 1 meter and 12 meters in 5 seconds. Substitute the known values into the kinematic equation, which gives two equations with two unknowns. Now, the first equation is for 1 meter distance and the second one is for 12 meters. Now, we will equate the equations of two distances to solve for acceleration. Then the result is equal to 1.375 meter per second squared. Now we can solve the value of distance away from the origin using either of two equations. Let us try to use the equation under 12 meters. Then the result is equal to negative 5.1875 meters as the distance away from the origin. Let us proceed to number 6. A car moves at a speed of 20 km per hour along a straight path. The driver suddenly brakes and the car comes to a complete stop after 5 seconds. Suppose that during the decelerating period, the car's acceleration remains constant. Now the question is, how far has the car traveled between applying the brake and coming to rest? In this problem, we can apply the kinetic formula to find the total distance between braking and resting points. But before we can use this, we need to find the value of the acceleration of a car because the only given values in the problem are its initial velocity of 20 km per hour and a time of 5 seconds. We will initially use the formula of final velocity to solve for the acceleration. Now, in this problem, the final velocity is equal to 0 because the car stopped after 5 seconds as a time a car travels with an initial velocity of 20 km per hour. Therefore, acceleration is equal to negative 4 meter per second squared. It means that the car decelerates before it stops. Then we can now directly use the kinetic formula. After we substituted all the values to the formula, the result for the distance traveled by car is equal to 50 meters. Now let us solve problem number 7. A motorcycle starts its trip along a straight path from position x sub 0 is equal to 6 meters with a speed of 9 meter per second at a constant rate. Now at position x is equal to 8.5 meters, its speed is 6 meters per second. The question is, find the displacement equation of this motion as a function of time. We'll use the kinetic equation. Substitute all the given values to the formula such as 6 meter per second as the final velocity at a distance of 8.5 meters and an initial velocity of 9 meters per second at a distance of 6 meters. Then the result is equal to negative 9 meters per second squared as the acceleration. Now, we can apply the kinetic equation with two unknowns to create another equation for a distance with a given time. Substitute the values to the given equation and give the result of a new equation as the displacement equation of this motion as a function of time. Let us proceed to our last example. Two cars start racing to reach the same destination at speeds of 55 km per hour and 118 km per hour. If the faster car reaches 2 hours earlier, what is the distance between origin to destination? The distance formula is the product of velocity and time. In this problem, it has two cars racing and we need to find out the total distance between the origin and destination. The distance traveled by S as a slower car and F as the faster car is the same. Therefore, we can now equate the formula of 2 in terms of distance. Then substitute the values. Let the slower car be equal to 55 km per hour with a total time t for covering the total path. 2 hours earlier for a faster car, say v sub f is equal to 118 km per hour with its time of minus 2. The result is equal to 3.75 hours. Now we go back to the distance formula. We can use either of the two, but let us use the distance formula of the faster car. Substitute the values to the formula and use the value of t or the time as 3.75 hours. Then the result is equal to 106.5 meters. You can also use the slower car to solve for the distance. That's all for today and keep safe everyone.